Okay, I'm going to run through an example that uses the Chinese Postman algorithm. Okay, so here's our graph, and notice that we've already been given the total weight equaling 42. So that's all of the edges, all the weights of the edges added up. Usually, on an exam paper, this will be given to you. If not, you will need to work it out. So what we do to start off with, and this is just to help you, I'm going to write down the order of each of the vertices. So we've got 3 here. Sorry, I'll take it off a thick pen. There we are. We've got 3 here, 2 up here, 3 here, 3 here, 2 here. G has 6 edges coming out of it, so it's even at 6, and H is 2. Okay? And the reason I did that was because I wanted to know which ones were odd and which ones were even. Okay? So what I'm going to do is I'm going to circle the odd vertices, sorry. Like so. Now I'm only doing this just to help me to see what I'm going to do next. So the odd vertices are A, B, D and E. Okay? So what I'm going to do is I'm going to now pair them off. So I could put A with B and hence D with E. Okay, so that's one possible pairing. I could have A with D and B with E, or I could have A with E and B with D. Okay? So the whole point in doing this is I'm going to find the shortest distance between each pair of odd vertices. Okay, so that if I then added those edges into my graph would then become Eulerian, and I would minimize the Eulerian cycle, which is the whole point of the Chinese Postman algorithm. He doesn't need to go down all of the roads twice. He wants to minimize his journey, in other words. So if we have a look at A to B, the shortest distance from A to B is 4. Now in the exam, you should usually be able to do these, look at these distances and find them by inspection. Okay? Otherwise you would have to use Dijkstra's, and you will be told if you need to use it. So D to E is 1. A to D, okay, is a little bit more tricky. We've got 5 and 1 is 6. Yep, that looks about it. So A to D is 6, going through G. And B to E will be 5. Or we could have A to E, and the quickest route for that would be 7. Okay, going from AGE or AGDE, same thing. And B to D will be 4. Okay, going via G. So BGD is 4. The next thing you do is you add the pairs up. So here I've got 5, here I've got 11, and here I've got 11. Okay, so I want to minimize my total distance. So obviously the one I'm going to pick is the minimum, the smallest of the 3. So I'm going to pick the 5. So if I added these edges in to my graph, okay, so A to B at 4 and D to E at 1. Okay. I've made my graph Eulerian, which means I can find an Eulerian cycle. Okay, a cycle that will traverse every edge precisely once, and then so I can traverse the edge traverse an edge precisely once. Okay, so the total weight of that will be 42. Okay, all the original edges added up together, plus 5, because I've added on one edge of weight 4 and one edge of weight 1. So the total is 47. Okay, so if these were distances, then the minimum the postman would need to travel is 47 miles, for example.